Assalamualaikum. My name is Muhamad Izzad bin Razali. Today I will present about my final year's project. My topic is thermal accelerated aging between treated waste cooking oil and mineral oil for transformer application. First, for the overview of my presentation, I will discuss about introduction, research motivation, problem statement, objective, scope, literature review, research methodology, and expected result, and lastly is conclusion and future work. For introduction, power transformers are the backbone of the world's electricity and distribution system. The service life of mineral insulating oil is typically 30 to 40 years for power transformer application. And insulating liquids are generally preferable because these liquids serve a dual purpose as insulator and coolant. And this project aims to investigate the performance of treated waste cooking oil under accelerated thermal aging such as breakdown voltage, acidity, and moisture content. Then my research motivation: insulating liquid are important part of electrical insulation system in lot of variety of electrical power equipment. Transformer oil is important to fill the pore in fibrous insulation, and additionally, the distance between the coil conductor and spacing among winding and the tank. And then about mineral oil behavior: low viscosity, equal availability, and modest fee. And the advantage are back in biodegradable and non-renewable. Then the natural ester oil or waste cooking oil as the alternative because it is more biodegradable and renewable. And high energy fault not degrade the transformer insulation such as oil, insulation paper, and pressboard, but it can occur oxidation. For my problem statement is transformer mineral oil has been replaced by alternative oil such as natural ester, palm oil, vegetable oil. Oil is chosen based on its biodegradability and environmentally friendly nature. It can cause pollution and contaminate the soil if there is a heavy leakage. And the mineral oil was extracted from the oil that will run out in the future, and the oil is non-renewable energy. And enhancing the production process and treatment of mineral oil has contributed to a significant price effect, and transformer oil cannot be used for a long time. And in addition, the use of waste cooking oil circumvent the problem of oil and food, which had become a hotly debated issue in recent years. And cooking oil consumption increased, and its consistent supply made waste cooking oil commercially viable. And approximately 3 billion liters of cooking oil are used in Malaysia every year. Only 30% of waste cooking oil food is available for biodiesel production, which translates to about 10% of diesel demand in Malaysia, which demand increase every day. And so, in this study, waste cooking oil was proposed to be a new insulating oil. For objective is to study the development of treated waste cooking oil by using neutralization process to investigate the performance of treated waste cooking oil under accelerated thermal aging condition based on breakdown voltage, acidity, and moisture content, to compare the performance of the treated waste cooking oil and mineral oil under thermal accelerated aging condition. And for scope of work is to study the process of neutralization in producing the treated waste cooking oil, to study the performance of treated waste cooking oil under accelerated thermal aging condition in breakdown voltage, acidity, and moisture content. Then to compare the performance between the treated waste cooking oil and mineral oil under accelerated thermal aging condition in breakdown voltage, acidity, and moisture content. Next, the scope of work is the Cal features colorimeter method will be conducted by referring the ASTM D1533 standard for measure moisture content. For measurement of total acid number is carried out using 848 tetranol plus using the ASTM D974 standard, and ASTM D1816 standard is used in analyzing the breakdown voltage of oil using Mega OST 60PB. Next, for my literature review is I will discuss about transformer oil, which is mineral oil and natural ester. For the types of mineral oil is refined crude oil based distillate, and for type of natural ester is refined vegetable oil or with cooking oil. And for principal component of mineral oil is complete mixture of hydrocarbon, and principal component of natural ester is plant-based natural ester. And biodegradability of mineral oil is slow to biodegrade, and for natural ester is readily biodegradable. And for oxidation stability of mineral oil is good stability, and for natural ester is general oxidation susceptible. And for water saturation at ambient of mineral oil is 55 ppm, and for natural ester is 1100 ppm. For flash point of mineral oil is 160 until to 170, and for natural ester is more than 300 degrees Celsius. And fire point for mineral oil is 170 until 180, and fire point for natural ester is more than 350, and the fire classification for mineral oil is 0, and for natural ester is K. Next, for stability oxidation, that will be discussed for the thermal accelerator AG by a little bit. Firstly, for the stability oxidation is negative effect for transformer oil occur when insulation oil react with oxygen to produce acid and water. Water content will increase when occur oxidation. Slug will form and be conductor. It can build up and block the oil duct. The flow of the oil could be disturbed and reduce the cooling efficiency of the transformer and cause leakage and short circuit. More stable when water content is low, acidity is low. Next, for thermal accelerator aging process. Directly related to the aging level of oil is insulation and primarily of fuel. When age goes reduce electricity properties and cooling efficiency, this could isolate the oil from its prevalent insulation and heat transfer characteristic. Many factors influencing performance and degradation of transformer oil or paper insulation and insulating breakdown such as breakdown voltage, acidity, moisture content. And insulating material are exposed to adverse climatic effect in the middle of an operating cycle, including temperature fluctuation in a relatively large range and temperature induced by loss of material strength. The change in temperature further affect the mechanical, electrical, and other physical and chemical properties of the protective material. And for transformer oil properties is breakdown voltage. Its prospect of failure is a given voltage. Achieve best insulation oil, higher value of breakdown voltage are required. Can prevent the oil from breaking down under electricity stress. Measure by application of voltage between two electrodes under prescribed oil condition. Dielectric test measure the voltage of oil, which indicate the amount of contaminant in oil. New oil should have a minimum dielectric strength of 35 kV by American Society for Testing and Material Method for Testing. Then for acidity, amount of sodium hydroxide in 1 gram of oil will neutralize the acid. The acid content of oil is indicative. Insert F oil, the presence of contaminants such as slug is also indicative. The transformer oil contain practically no acid. The acid test measure the content of oxidized acid. Then for moisture content, main role of oil in the transformer is to which provide electrical insulation. When the moisture property increase, the oil property are reduced, which affect the breakdown voltage. At the same time, the oil properties are important if the temperature change where the transformer is cool and oil is produced. Humidity in the oil is measured in part per million ppm by the moisture weight divided by the oil weight. Water can be dissolved in oil as very small droplet mixed with oil or in a free state at the bottom of the oil tank. Next, for recent methodology, this is a flowchart of thermal accelerator aging of waste cooking oil. This is an overall flowchart from the oil sample properties check, property with limit set by standard, and thermostatic aging for treated with cooking oil, then testing oil sample after the aging and compare the properties of thermostatic aging between the with cooking oil and the mineral oil, then data analysis and end. Next, this is a flowchart for thermostatic aging process with a treated with cooking oil and the characteristic for thermostatic aging arrangement, temperature, volume of sample, duration aging, and metal catalyst. Then testing oil sample after the aging and data analysis. Then end. For methodology experiment setup is a preparation for process neutralized to get sample treated with cooking oil. Mix 2020 gram nitrile hydroxide and 250 milliliter distilled water. Stay in 50 minutes to soluble the mixture. There are a step to get the treated with cooking oil. Then testing oil property breakdown. We using a measure, and the range temperature for the oil is 20 until 30 degrees Celsius. And the value of oil testing is 500 milliliter. Then for moisture test, we use a coefficient titration, and the oil sample will be calibrated of the width. The width of oil will be calibrated before testing moisture. And for acidity, I use a Tetrano Plus with standard ASTM D974. And for project milestone, first search the topic, second search reference, third literature review of project, fourth thermostatic aging process related to oil parameter, 5 compare properties of thermostatic aging of treated with cooking oil, and 6 record and collect data, 7 analyze the result, and 8 report writing. For result for development of treated with cooking oil, for breakdown voltage, the average value 48 kV. For water content is 87.5 ppm. For acidity is 0.4244 mg/kOH per gram. And this is a result for breakdown voltage for thermostatic aging of with cooking oil before and after. We can see before aging is 48 and after aging is 31. Then for moisture content for treated accelerated aging of cooking oil, before aging is 87.5 and after aging is 209.4, which after aging the moisture content will be increased. Then for acidity for thermal accelerated aging of cooking oil, before aging is 0.4244 and after aging is 4.7723, which is highest in the after aging. For comparison, for moisture content between treated with cooking oil and mineral oil, for the 0 hours, treated with cooking oil is 87.5, and after 500 hours, the moisture content is 209.4, and for mineral oil 110 degrees Celsius is at 0 hour is 80.3, and also same with the mineral oil 130 degrees Celsius is 80.3 ppm. And for the 500 hours of mineral oil with 110 degrees Celsius is 34.5, and the moisture content for mineral oil 130 degrees Celsius at 500 hours is 42.3. For comparison of acidity, treated with cooking oil at 0 hour is 0.4244, and for 500 hours is 4.7723. And for mineral oil at 110 degrees Celsius at 0 hour is 0.0442. Same with the mineral oil at 130 degrees Celsius, which is 0.0442 ppm. At 0.5 0.0442 mg/kh per gram, and for 100 hours at mineral oil 110 degrees Celsius is 0.1793, and for mineral oil 130 degrees Celsius at 500 hours is 0.169. Then comparison of breakdown voltage at 0 hour for treated waste cooking oil is 48, at 500 hours for treated waste cooking oil is 31, and for mineral oil at 0 hour is 28, and mineral oil at 500 hour is 24. And lastly, for conclusion is acidity, breakdown voltage, and moisture content which limit standard of property oil before thermal extracted aging. The property of oil such as breakdown voltage, total assay number, and moisture content are good result before thermal extracted aging compared to result after thermal extracted aging. The short duration of aging will give the best quality of property compared to long duration and will be related to quality of oil. Value of temperature and period of aging has given the different performance for oil sample. Mineral oil have best performance for moisture content and acidity compared to treated waste cooking oil because it has a lowest result for property of oil. Treated waste cooking oil has good performance in properties of breakdown voltage compared to mineral oil, and mineral oil can be most good insulation to be used in transformer application compared to treated waste cooking oil. For future work, aim on thermal extracted aging process to improve quality for future transformer application. The use of catalyst should be reduced to avoid more sludge produced after the aging, and apparatus must ensure in good condition before start the testing. And for future of paper of insulating oil, study the tensile strength for choose best insulation oil for cellulose paper in transformer application. That's all for me. Thank you.